Hey guys, this is the second video of a three-part tutorial where I'm sharing how to calculate how long and how far a scroll rect will scroll after the user ends a swipe. In this video, we're going to derive the equations for distance and duration from the deceleration equation. The only prerequisites are that you're comfortable with algebra and you understand the purpose of time.delta time. Actually, there's also one line of calculus, but we'll have a cheat sheet that tells us exactly what to do. In addition, you can find some helpful links in the description. We'll start with duration because that one's a little easier. So we're trying to figure out t. Vf, final velocity, is equal to v0 times r to the power t. And we want to get t by itself, so we do Vf divided by v0 equals r to the power t. Now we have to get t out of the exponent, and we can do that by taking the natural log of both sides. So we have the natural log of Vf over v0 is equal to t times the natural log of r. And now we just have to isolate t. So we have the natural log of Vf over v0 divided by the natural log of r equals t. So there we have it. We solved the equation for duration. Now for distance. Keep in mind that calculating the distance traveled from velocity is equal to area under the curve. Unfortunately, we can't use this equation that most of us learned in middle or high school because it only works for constant acceleration. In other words, when the velocity time graph is a straight line. This is where that one line of calculus comes in that I told you about. We have to take the integral of the exponential function. So the distance traveled over time t is equal to the integral of the initial velocity times r to the power t with respect to time. Initial velocity is just a constant, so we can move that outside of the integral calculation. Taking the integral of an exponential function is a common task in calculus, so lucky for us, Wikipedia tells us exactly how to do it. The last equation is the one we're looking for. They're using different letters, so let's substitute a with r and x with t. And c represents a constant, but we don't have a constant in our exponent, so we can ignore that part. And that's it for the calculus. Just copy this over and we're back to basic algebra. So we have v0 times r to the power t divided by the natural log of r. And when taking integrals, we also have to add a constant c at the end. If you're not comfortable with calculus, there's plenty of tutorials that'll explain why. So if we assume the speed at t equals 0 is 0, in other words, if we start at the origin, 0, 0, then we can easily solve for c. 0 equals v0 times r to the power 0, because we substituted for t, divided by the natural log of r plus c. And any positive number raised to the power 0 is 1, so we can replace that with 1. Now we have c equals negative v0 times 1 over the natural log of r. So now we have c. Now we can plug that back into our original equation and then continue. So we have v0 times r to the power t divided by the natural log of r minus, because that's a negative sign, v0 times 1 divided by the natural log of r. And if we look back at the duration slide, we can see that r to the power t is equal to final velocity over initial velocity. So let's go ahead and make that substitute. Vf over v0 times v0 over the natural log of r minus v0 over the natural log of r. So we can cancel out the two v0s, and the denominators are the same, so we can combine this into a single fraction. Our final answer is Vf minus v0 divided by the natural log of r. While we're at it, let's go ahead and derive the equation for deceleration rate r. Using the distance equation, all we have to do is swap the distance with the natural log of r, and then take the exponential of both sides to get rid of the log. In the next video, we'll finally open up Unity and implement these equations.